Hello. Hello. Am I on? I seem like gone. All right. First things first. Got to pump them up. All right, we're ready. So this is a carton of NIST 1082 cigarette ignition strength standard. Anyone heard of it? No? Probably not unless you're a fire safety enthusiast, in which case weird flex, but yeah, all right. Oh. Now the story behind NIST 1082 might surprise you, especially if you're younger than, I don't know, 40 something. For decades, the principal factor in fatal house fires in the United States has been the ignition of soft furnishings, things like beds, chairs, mattresses. A bed is actually surprisingly easy to ignite through things like a lit cigarette being dropped on it. And worrisomely, contains enough combustible material to rapidly fuel and grow a fire. As you can see, this is a chair, this is just a chair, and in about a minute, there's not much chair left. And if you're asleep sitting on that, then there might not be much of you left either. And what's surprising to me is that a lit cigarette only generates about 8 watts of heat. And some of that heat is used to continue the cigarette's, combustion. Some of it gets radiated out to the surrounding environment, and some of it, in this case, is transmitted to whatever is touching. In 1976, the predecessor of NIST, which is an organization called the National Bureau of Standards, realized they needed a way for manufacturers to gauge the fire safety of their soft furnishings. And so they did a bunch of research, and they said a king-size unfiltered Pall Mall cigarette is the strongest igniting commercial cigarette on the market. And so this became the de facto, and in some cases de jure, standard for ignition tests. These ignition tests were really based on this thesis, right? That we can reduce the number of fatalities, we can reduce the number of injuries, we can reduce these negative consequences of cigarettes being dropped on things and catching on fire by testing how easily the furnishings ignite. And this is a pretty solid, thesis, right? You don't want things that are going to be in someone's house to just turn into a roaring inferno. NIST, however, later on went a step further and said, well, wait, it's great that we're testing the materials, but what if we could change the cigarette? Like, is there something we can do on both sides of this equation? And that is how NIST 1082 came to be. It was a collaboration between the US government, between commercial cigarette manufacturers like Philip Morris, and they worked together and said, how can we make a safer cigarette? This has been something that there's been a ton of interest in for decades. You can go all the way back to the 1800s and find patents for cigarettes that will go out on their own, but it didn't actually happen until like the early 2000s, weirdly enough. And what some researchers at Philip Morris found was that if you take a cigarette and you add some cellulose bands inside the paper, then those bands will act as a stop, where the cigarette will stop burning when it hits those bands unless you're actively drawing on it. It doesn't change the flavor, it doesn't change the composition. It was just, hey, we can make a cigarette that is less likely to cause these kind of fires by making it go out on its own. And so even more standard tests were created to work with this new cigarette. And if you look at the data, then it worked, right? States started to mandate this self-extinguishing cigarette, and over the next few decades, we can see a remarkable drop in not only deaths, but also just household fires in general. And what's important here, I think, is that it didn't just focus on the outcomes, right? They didn't just say, hey, we're going to make safer mattresses, we're going to make more fire retardant, sprays to put on our couches. We're going to actually make a safer cigarette. And doing so cut the number of fatalities by 30%. So what the hell does this have to do with OpenTelemetry? And I'm glad you asked that, because this is the hater's guide to OpenTelemetry. I'm Austin Parker, Director of Open Source at honeycomb.io, a longtime maintainer of the OpenTelemetry project. And if you are a OpenTelemetry hater, hands? It's fine. I'm raising my hand. I work on the damn thing. All right, how about OpenTelemetry lovers? Okay, I'm pleased that there are more of you raising your hand for that. And who's never heard of OpenTelemetry? A couple of you? All right, well, you all should come to my book signing tomorrow. You'll find something to enjoy here regardless of where you sit on that spectrum. I opened this talk talking about standards. And when you get down to the heart of things, that's what OpenTelemetry really is. We don't call it that because the CNCF, Cloud Native Computing Foundation, is not a standards body. We are not IETF. We are not W3C. So officially, OpenTelemetry isn't a standard. But if you look at how we work, why we work, what we're doing as a project, then it's to those ends. Standards are a really funny thing in software, I think. A lot of times they're like Monopoly. Everyone has their own version of Monopoly house rules because the rules as written kind of suck. And as you might know, standards really often aren't, right? Think about email. Who uses Gmail? Okay, do you know what part of the email spec lets Gmail thread your emails? There isn't one, correct. Threading doesn't exist in SMTP. It doesn't exist in POP, right? These low-level standards don't have a lot of the affordances that we expect as users. And so if you want to build threading into an email client, then, well, have fun. You have to do it yourself. And if you've ever tried to migrate from Gmail to Outlook, or I should say Gmail to Exchange, you might know that there are a lot of weird little inconsistencies, shall we say, between how different systems handle something as simple and straightforward as email. And it's not just stuff like email, right? Email's been around forever. That's an easy one. Let's look at something like OIDC or OAuth 2. Oh, what's this? Google doesn't respond correctly and is very, in some cases, to OIDC claims? Let's think about ActivityPub. Oh, but if I talk about ActivityPub, I'm actually talking about Mastodon because when you only have one thing that really implements a standard, what it actually means is that you have that one thing. And the standard is kind of like the parts of it that are inconvenient or inadvantageous for the product developers get shuffled aside a little bit. And it's not just email. It's not just OAuth. It's not just ActivityPub. It's literally every standard. Who was around for the browser wars? Who remembers IE5? You know? Like, this isn't a... It's very easy, I think, as a developer to say like, oh yeah, standards are going to solve all these problems for us. Because then we can just do like a clean sheet design, we can implement the standard. But in the real world, standards have to, exist in this melange of other things. All of these different tools, this is just the CNCF observability landscape, and all of these different things have their own little quirks, even for roughly the same data. There's StatsD, right? There's Prometheus, Micrometer, all sorts of logging APIs, everything from Apache, common log format, to whatever madness your principal engineer dreamt up 15 years ago that you still have to use and deal with. And a whole host of other proprietary formats. And so when you're a standards project, or you're working like a standards project, and you say, okay, I need to interoperate with this, then suddenly you have a lot of problems to solve. And these problems lead us to our first hater's thesis about OpenTelemetry, which is that OpenTelemetry is fundamentally unnecessary. We've all seen this. I've seen this more in the past 5 years than I would ever like to again. And the reason that we see this is because we like to hold this up as a proof point of, hey, OpenTelemetry worked, it's solving a problem. And in a lot of ways, yeah, we did actually reduce the number of standards by 1. But there are so many pieces of prior art out there. And so people ask, and I think it's a fair question, why are you trying to replace them? Why did you create your own metric specification? Why are you doing stuff with logs? Why are you adding in profiling? Why not just stick to tracing? We need a tracing standard. We don't need all this other stuff. Well, I tend to believe that the evidence historically shows it doesn't work. There's a lot of examples, great innovative ideas that didn't really gain purchase because they required too heavy of a lift to integrate with other existing tools and standards, right? show of hands, like how many people in their, in a 6-month period at the same company use more than, 2 different observability tools? Wow, literally everyone. Cool. These things proliferate. And you get one thing and you get another thing, and this team is using X, Y, and Z, and a team other here is using foo, bar, baz. And trying to integrate all together, which a lot of people here and elsewhere are trying to do, right? You want your single pane of glass. That becomes really challenging because there's all these little one-off differences between logs, between metrics, between traces, between different implementations of the same thing, or even the same thing across different languages. And this comes to a really awkward conclusion, which is that OpenTelemetry is actually a huge threat to existing tools in this space. Some people would actually argue that you can't have a meaningful standards-making process when you're competing with incumbents like this. And I think it gets to this point exactly. If you look at how people build observability tools, then telemetry is the core, it's the bottom, it's the thing that keeps everything else going, right? And it's actually really hard to think about this differently, because historically, all of this would have been integrated, right? You've heard of 3 pillars, so I like my 6 layers instead. And the base here of data is what underpins every single monitoring and observability tool since the beginning of time. If you don't have data, you don't have anything. And if you vertically integrate all these, right, then it's much easier to build a product because you know what to expect at every single step. You can make both micro and macro optimizations about your storage and about your query, about how you project those queries, about what are acceptable forms of math to do. But OpenTelemetry comes in and says, oh, hold up. We're going to do these 2. We got your data, and we got your pipelines. Everything else, that's up to you. All of those optimizations go away now. You have to either transform the data into what you expect, or you have to build something completely new. And I've joked about this, but I think it's mostly true, that if everyone had endless free money and endless engineering time, OpenTelemetry wouldn't exist because everyone would just write their own version of OpenTelemetry, which is broadly what the industry has done up until OpenTelemetry, right? Like, it's not good for vendors for you to be able to just say like, oh, I want to go over here now and take all your data and pop it into someone else's storage engine. I mean, it might be good in a spiritual sense, but it's not good for their salespeople's quota. So I think this comes to the biggest reason that OTel is a threat is because it is something that is so good for end users, but it's so risky for companies and providers of observability tools. And end users are, I believe, and I think the evidence shows this, that you are better suited by it, and that's why you're choosing OpenTelemetry. The second hater's thesis about OTel is that it's boring. Well, I don't mean boring in the sense that it's unexciting. Do you like naming things? Do you like renaming things that were already named 2 years ago and breaking everyone's stuff? Then you'll love OpenTelemetry in that case. And seriously, I'm joking, but there have been some people that say that, oh, we're setting our sites too small. Like, why did you build this whole thing and then come out with, metrics and traces and logs again? So I'm going to get there, but I'm going to get there in a backwards way. So stick with me. We actually really, really like stability in OTel. I'm not kidding. We really love stability. Now, the reason why is because our vision as a project is that if you are developing a framework or a standard library or something, then you should integrate OpenTelemetry into that, right? You should integrate our API. And then your users will just be able to plug in an OTel SDK and get telemetry out of it. Great. Where this maybe gets a little awkward is that we make a distinction between the API and the SDK API, and we're a lot more fond of changing one of those than the other, and you can guess which. But that insistence on stability and about slow change actually has caused a lot of stuff that I would kind of call permanent beta, or permanently 80% done. This is very hard to see, I'm sorry, but this is a graph of issue age in the OpenTelemetry specification repository. And it's from basically the beginning of the project to now. And what it's actually showing is that for about the first, I don't know, 2 years, our average issue time, or average issue age was something like 18 weeks, almost 20 weeks at points. Things changed very slowly because it was a standards making process, right? It was deliberative. It was try to get a bunch of stuff in. And we have changed some things, and you can see over here, starting around this time last year, we've got that down to more like a week or so. And some of this is because, the project's matured. We've gotten a lot of these tricky, thorny, got to get everyone on the same page stuff done, and now it's more smaller, easier things. But there's a lot of, I think economists like to call these externalities that have cropped up, and one of these is semantic conventions, everyone's favorite topic. And this is the cause of most people's pain, I think, in OpenTelemetry. Now, looking back, maybe this was predictable. I mean, who could have possibly predicted that it'd be so hard to get several hundred engineers to agree on what to call things? This is the commit history of the OpenTelemetry Semantic Conventions repository. Every day is 0.2 seconds. And so you're seeing about 5 years of history on this slide. Semantic conventions for HTTP spans recently stabilized, and it took about 4 years of work to do it. Those 4 years saw about 16 different individual contributors making changes into the span document, and it consists of 17 different attributes that represent the gamut of useful metadata about requests or response in an HTTP system, method, response headers, so on and so forth. Now you could ask yourself, how on earth did it take you 4 years to figure out what people care about when it comes to an HTTP client or server? Fair question. But, like I mentioned earlier, standards are a funny thing. Everyone has their own weird little one-off ways to do stuff. For example, did you know that quite a few people will pass API tokens through query parameters? I didn't realize that. There's actually some okay reasons for it. But suddenly, when you are putting those into another system, that can be a security issue for some folks. There's so many different competing priorities. Every company does things their own way, every org, every team. And trying to come up with a single, generally useful way to describe that takes hundreds of contributors 4 or 5 years. And people don't really, know what the problems or where the cuts are going to be until they actually use it in anger. And that's what the process reflects, right? I think this is a question about who does this pace benefit? Does it benefit you if you are, an SRE or a developer that had a mandate that you need to switch to OpenTelemetry, and so you need to rip out everything and put it into OTel land? Is it good for you? Maybe. If you see it as an impediment to getting your job done, probably not. But if you think of it as a step towards a commodity instrumentation layer that will take years to actually promulgate across the ecosystem, then I would say that deliberate pace is actually pretty good for you. This is not working well. I think this pattern echoes throughout the project, right? If you look at the schema transform processor in the collector, this is the thing that's supposed to save you from changes in semantic conventions, right? Because it lets you update your conventions as they change, lets you update your data. Cool. It doesn't really work like you would expect it to, is a problem, and one of the reasons is that there's a question. What happens if a schema transform processor tries to override an existing attribute value that you already set? How do we merge these? This question was asked in 2021, and this screenshot's from yesterday. So yeah, we haven't figured that one out quite yet. And this blocks future work on that processor, right? Because you can't actually finish it. It can't be done until you have an answer to this question of how do I handle competing values here? There's a lot of other things that have to be answered to get to that point. And here's the problem for you as a user. How would you know this? Because if you go to you are browsing through the OTel website, schema transform processors are great. But there's all this other implicit knowledge you need. You need to know that, what do these different stability levels mean? You need to know that there's a ton of examples and documentation and notes scattered across several different GitHub repos, and you need to know that if you go into this repo and go to this examples folder and then go like 3 layers more deep, you will find an actual working version of this. And then if you go over here, you'll find like the load-bearing comment that props up 90% of, you get what I'm saying, right? There's a ton of implicit knowledge that we don't communicate to you as a project because there's a lot of reasons for that. Some of them are good, some of them are bad. And this is one of the challenges we have, is that the core part of the project, the core of OpenTelemetry, actually works really, really well today. I would actually argue that in some ways it is one of the best telemetry libraries out there. But when you want to get creative, when you want to do stuff that's a little off the beaten path, then you can suddenly get into the there be dragons part of the map. And unless you have all this implicit knowledge about where to find stuff and that you have to go digging through these issues and you have to like read the code sometimes, then you're going to have a bad day. And I'm not saying to put people down or to say like, oh, we've done a bad job. Like OTel is a huge, complex, sprawling project, and it's worked on by volunteers, right? Even if our day jobs are be OpenTelemetry contributor, that's not all you do. I have, in my past 5 years, defended OTel, defended engineering effort on OTel to managers, directors, vice presidents, CEOs, and founders. I'm not saying this to like big up myself or whatever. I'm saying this because open source is, great for you as a user, but companies do need to be convinced quite often that it's a worthwhile, investment in time. I do want to say though, like despite all this, like we are very successful, right? Like if you look at contributions over time, it just keeps going up and up and up. We're solving a problem for people. OTel is being integrated into so many surprising places. If you have Docker on your laptop, if you go into your shell environment and set the OTel, OTLP exporter endpoints for traces, and then you run like a Docker Compose command, Docker Compose has traces. It will emit OTLP traces for you. It's really cool. And that's the vision, right? That you have all this telemetry just sitting down here underneath everything, quietly existing until you need it. And at which point you say, here's my collector, go collect the data, go put it somewhere, pretty graphs, pretty charts, and then we all take off at 5 and go to the bar. So I do want to ask, right? The position of the hater is that OTel isn't innovating, that it's boring. And I think that a lot of this is because it's not necessarily supposed to be exciting. Like we're trying to make commodity instrumentation. We're trying to make telemetry just a thing that happens in the background that you don't necessarily have to think about. You only have to think about it in the sense where you want to extend it. And that's a big change from how we've traditionally approached this. Traditionally, you would drop in some third-party agent and it would give you a bunch of stuff and you'd be like, great. Well, what if you don't need the third-party agent? What if all that telemetry is just there as part of Spring, as part of Express? And then you get to go in and annotate on top of it. So to that end, like, let's talk about what is innovative about OTel, right? In OTel, everything is an event. The Honeycomb people will like this. Everyone else will groan. That's okay. You can groan. I'm going to make them groan in one more slide. So, but everything in OTel is just, hey, there's all these events that are happening in your software. We give them a schema. We give them a common format. We give them semantic conventions so that consumers can understand what things mean. And this gets missed a lot because people see metrics, logs, traces. They see events and profiles, and they connect those up to their existing metrics, logs, traces, events, profiles, whatever, workflows. But yeah, we're just creating data and putting a schema on it, and it's kind of up to you to figure out the interesting parts of that. And this is the part that makes the Honeycomb people groan, which is that most of that data is really boring, and it does need to be pre-aggregated quite often, right? Like it does need to be sampled. Most of the stuff that's happening in your system at any given moment is not fundamentally interesting. The thing is that your telemetry doesn't know that. Your telemetry needs to kind of exist in a stateless way. It's up to higher parts of the observability stack to figure out, is this actually interesting or not, right? It's up to the pipeline components. It's up to sort of stuff at the storage layer. And one of the reasons that we did take so long to do some stuff like metrics is because we wanted to make sure that you could do those aggregations without losing data, or at least without being able to, without being able to get yourself into a state where you were losing stuff and didn't know why. Like if you've ever tried to combine summaries in Prometheus. Oh, right, you can't. But you can with OTel histograms, right? It takes a while to figure out stuff like this. A lot of the thing, why are OTel metrics complicated? Because they're supposed to represent this very much larger sort of space around schemas and semantic telemetry than we currently have. Now, the problem for you is that most of the tools out there ignore all that, right? And I know this is a cop-out to say like, well, the industry will catch up. I know this sucks now, but just give it a year or two. And I'm biased because I'm in the weeds on it, right? Like, I wrote a book on this, for crying out loud, right? Like, I'm on governance committee. I have a privileged position. Sometimes I learn things that take me aback, like people not realizing that you can actually have multiple pipelines in an OTel collector for the same data, or that you can take a single pipeline and kind of tee it out to multiple destinations. There's stuff that I take for granted that is very surprising because it's not conventional for people. And this leads to the third and final hater's thesis, which is that OTel kind of sucks to use. I'll give the haters this one. It does kind of suck to use sometimes. I will make some qualifications here. It depends on what you're trying to do, and it depends on what you're talking about. A lot of people say the docs suck. Well, when was the last time you looked at the docs? I would say they're the worst they'll ever be. They get better every day. We've actually made a ton of improvements in documentation over time. Now, what's interesting is that the reason the documentation is kind of in the state it is because we learned something from open tracing and open census, which is that highly centralized project governance has downsides. If you want APIs to look like Java everywhere, then centralize your project governance. If you want them to feel idiomatic, then federate your project governance. And in some languages, we have that. I think Java OTel is actually pretty good at feeling like Java-y. Python pretty good at feeling Python-y. .NET is so idiomatic, you don't even have an OTel API, you have system.diagnostics. But all those things make it harder to have a central documentation store, especially as things change. The biggest thing you learn is that governance is actually a really leaky abstraction. The way your project is governed has a lot of knock-on effects as to the rest of it. SIGs wanted to keep docs close to the code. So if you look at the repo for OTel Go, you'll see this examples folder with tons of examples. Same thing with JavaScript, same thing with Python, Ruby, whatever. If you go to the website, then you don't have all of those examples. Although, like I said, this is changing over time. But I think that what we learned that if you have this sort of federated governance, then that will show up in certain ways. The other thing we've learned is that there's a mismatch between user expectations and what OTel actually offers as a project. People expect, drop-in solutions. They want copy and paste example code. They want you to take their hand and lead them down the garden trail of how to instrument the Spring app, which is great. I respect the desire. We are not designed for that, right? We are designed for holistic full system instrumentation. We're unopinionated about what you do with the data once you have it. It makes stuff like the demo really challenging, right? Because the demo is supposed to be, look at all this cool stuff you can do, and it looks just like a Grafana dashboard, because that's all we can really show you. The tools aren't necessarily up to where we need them to be yet. How many of you use the collector, right? Like, how many of you like using the collector? Because we have this mismatch. We kind of expect you to use the collector, but you're not required to. If you were required to, we actually could probably make a lot of different design decisions about the project. And ultimately, like every talk here, it comes down to being a people problem. It's easy to look at OTel and say it's broken, it sucks, or it has problems. But why does it have these? A lot of it is because of our desires, our demands, what we expect or what we want out of telemetry and observability systems. I've come up with this, the ARS theorem. The E is silent. All right. But it's all right. So the CAP theorem, right? Consistency, availability, partition tolerance. Pick two. With this, you can't even pick one. You're trading off. You want to, make these trade-offs in your observability system. You're saying like, if I want faster queries, then I need to reduce the resolution. If I want to have more data available, then that's going to mean my queries are slower. You're making all of these different trade-offs, and OTel can't actually be opinionated about which one of these trade-offs is for you. We have to support people that are going to make different ones, that are going to sit at different parts of this triangle. And that leads me to this graph again, because I showed you this graph earlier, but I omitted a key piece of data from the chart, and I'm wondering if anyone picked up on it. So yes, look at how great those safe cigarettes were. But let's look at this chart. We did have over 50% drop-off in fires started in bedrooms and living rooms. Unfortunately, it seems like those fires just started outside instead. In fact, 17 times more fires started outside. And why is that? Well, we started to ban people from smoking inside. We started to use these things called smoke alarms, smoke detectors. And as you can see, that led to a precipitous drop in smoking. So yeah, if you tell people you can't smoke inside, then they're probably not going to light their mattress on fire as much, are they? The standard was a part of leading us here. The standards helped. It did make stuff safer. We can look at this chart to prove it. But the standard wasn't the solution. The solution was changing how people behaved, was changing how people thought about this. Standards aren't magic. They are kind of slow and they are kind of boring. OTel is not magic, and it can move kind of slowly, and it can be kind of boring. But it's easy to get caught up in this magical thinking around it. It's easy to get caught up and say like, oh, this is the solution or the cause of all of our problems. And I think the important thing to look at is like, well, with that aside, why are people using OTel? Because it does solve this real problem for people of vendor agnostic telemetry, of holistic full system instrumentation, of being able to correlate between these events and being able to do it without being locked into one particular vendor or API or whatever. And I think this is where I want to leave this conversation. OTel's success or failure is not up to me. It's not up to any of our contributing companies. OTel will succeed or fail because of the community, because of people like you that take it, see the vision, and run with it, that build the next generation of tools and analysis on top of the data that OTel is providing you, that you will be integrating this into your systems, into your lower level stuff. And if you want to talk more about that, I have a book signing tomorrow that you can get a free copy of my book. It's great. At the end of the day, you are the answer to these problems, to all of the problems I've put here. The standard isn't going to save you from anything. It is time for you to take the ball and run with it. The future of the future of observability isn't OpenTelemetry. It is indeed all of you. So thank you for your time. I am way over, I'm pretty sure. So any questions can go in class, or I'll be out in the back.
All right, we've got time for maybe a couple of questions.
Okay.
Yeah, I'm going to give you a couple. You don't get off the hook easily here. All right, I got a question right here. Yeah.
Say what? Oh, book signing. If you go up to the Honeycomb booth, we have a QR code you can scan. It's like it's Urban Studio. It's like right down the street at 5 p.m. tomorrow. But we're going to have a signature cocktails and mocktails. The drink is OpenTelemetry. Thanks. Whoever booed me, that's why I made that joke.
I felt it would have been rude for me to boo with the microphone. So
no, I expected nothing less, Pete. Any other questions?
Find someone over here. Anything up the top? I always forget you people up top.
What's OpenTelemetry?
What's in it? It's blue Caraco, vodka, lemon, some sort of lemon liqueur. It's going to be like blue and yellow.
Is that pronounced Caraco? Is that?
I actually don't know how to pronounce it.
Okay.
I'm from Kentucky. Carasso?
Carasso?
Carasso? Okay.
Curacao?
All right. Specifically, I'm from Eastern Kentucky.
All right. Any other questions? Oh, we got one right here.
Profiling is events at the. Profiling is also a series of events, but at a finer resolution than a span, right? Like a span is a logical human piece of work, and then a profile is a collection of like, line of code events. It's the same basic principle, just the difference is what's the resolution of the data. And there's also differences in how you collect it and da-da-da-da-da. We have actually, yeah, did anyone see the Elastic Profiler got donated to OTel, so that's going to be exciting. Yo.
Could you say to previous speaker who told us that we have too many metrics?
Do we have too many metrics?
In general, we have too many.
We probably do. I would say that the idea with OTel is that you should be using the right signal for the job, right? Like some things are really good to keep as a metric because if it's numerical data, if it happens over time and you want to kind of retain that data for a long period of time, right? You're making a trade-off between resolution and availability of what the data actually represents. The great thing about OTel is that you can also then say, for stuff that doesn't need to be a metric, I have a log or a trace or whatever.
Too many data, too many monitoring data.
Right, like the reason you have too many metrics is because you have too many things you're trying to make metrics, is my opinion.
At the same time, Hotel is adding more and more data. Is it really useful?
I think it's useful. I think the point with OTel is that, sorry, the question is, I have too much data. How do I deal with all this data? I think the thing to keep in mind is that OTel actually provides ways that you can use that data intelligently with each other to make decisions about what to keep and what to throw away. I said in my talk, most things aren't interesting without pre-aggregation of some sort. And that's true. Most spans, most logs, most metrics aren't interesting. Your system is either in a steady okay state, in a steady everything is on fire state, or most of the time it is in this big in-between where some things are broken and some things aren't broken. So how do you know what to keep? Well, you want the stuff that tells you why it's broken in bad ways, and then maybe you want less of the stuff that's like why it's broken in a way that I don't care about. And to actually make those determinations, you need to actually combine those metrics, those logs, those spans, together and use the correlation, the schemas, and the semantic conventions that OTel provides, the hard and soft context, to make decisions about what should be kept and what should be thrown away. So I think I am being gonged off the stage in favor of wonderful, wonderful friends at Chronosphere.
All right, another round of applause for Austin.